What's up viewers? Ang video na mapapanood nyo ngayon is about analysis of singly reinforced beam under balance condition. So samahan nyo ako sa talakayan natin ngayon simula nga sa matapos yung video na to. So by the use of the provisions of NSCP 2015, aalamin natin kung ano yung indication para masabing under balance condition yung beam with tension reinforcement. So, makinig at eto na yung lecture natin. So, pagdating natin sa balance condition, so pag sabi nating balance condition, mag-yield yung steel pag na-achieve na ng concrete yung maximum strain na 0.003. So, ibig sabihin, once na mag-commence na or once na magsimula na yung rupture ng concrete, tsaka naman mag-yield yung steel. So, ibig sabihin, sabay yung yielding ng dalawa. Kaya sila tinawag na balanced reinforcement. So, let us recall na dun sa una, sa tension controlled, mauna mag-yield yung steel before sa concrete. While dun sa compression controlled, hindi mag-yield yung steel kasi mauuna mag-fail yung concrete. In this situation, sabay sila. So, ibig sabihin, yung tensile strain ng concrete is equal to the yield strain. And ito, so kung masuriin nyo, ito yung B, ito yung effective depth, ito yung area. So, ito yung balance steel area. So, ito yung depth of the neutral axis. Ito yung compression block, 0.85 F prime C. Yung T natin is equal to AS FY. So, ito AS balance. So, if you make ratio and proportion dito, magiging C is to 0.003 equals yung D natin. So, D is 2 yield strain plus 0.003. Okay. So, dahil yung tensile strain natin ay equal sa yield strain, so using Hooke's law, yung yield strain natin is equal to Fy over the modulus of elasticity of the steel. So, balik tayo dito. So, alam natin yung modulus of elasticity ng steel is 200,000 MPa. So, now, so itong mga variable lagay natin dito. So, we have C over D is equal to 0.003. Yung yield strain, palitan natin itong Fy over Es. So, we have Fy over 200,000 plus 0.003. So, ayusin lang natin yung yung fraction na to. So, alisin natin to. So, multiply natin by 200,000 over 200,000. So, multiply natin dito para umayos ang equation. Ito, 0.003 times 200,000 is equal to 600 over. So, ito naman, pag multiply dito, magka-cancel lang yan. Magiging Fy plus 600. So, cross-multiply natin yan. Yung C natin or yung depth ng neutral axis is equal to 600D over 600 plus Fy. So, ito na yung value ng ating C under balance condition. Now, so, since this is a couple, so, a couple of forces, yung C natin dito is equal to T. So, we have C equals T. Wherein yung C natin is ito, stress times area. So, 0.85 Fc prime multiplied by AB is equal to AS balance times Fy. So, yung A natin is equal to beta C. So, beta factor multiplied by C. So, galing yan dun sa So, same lang yan sa mga previous NSCP. So, galing yan dito. So, substitute natin 0.85 Fc prime. So, beta C times B equals AS balance Fy. Now, yung raw balance natin is equal to AS balance over BD. So, substitute natin. So, ito from here, magiging AS balance is equal to raw balance BD. So, substitute natin dito. So, magiging 0.85 Fc prime beta C B equals raw balance multiplied by BD Fy. So, pwede mag-cancel yung B. So, makakuha natin yung balance still ratio. So, yung raw balance is equal to raw balance natin is equal to 0.85 Fc prime multiplied by beta C over FYD. So, di ba kanina, yung C natin is ito, 600D over 600 plus Fy. So, substitute natin. So, magiging raw balance is equal to 0.85 Fc prime beta multiplied by 600 D over 600 plus Fy multiplied by FYD. So, magka-cancel yung D. Therefore, raw balance natin is equal to 0.85 Fc prime beta times 600 over 600 plus Fy multiplied by Fy. So, ito yung formula natin sa balance steel ratio. So, since na-derive na natin yung formula sa depth ng neutral axis, yung C, and yung raw balance, so pwede na tayo magsagot ng sample problem. So, ito yung problem natin. So, sabi sa problem, a beam has a width of 300 mm and has an effective depth of 500 mm. So, ito yung width, 300 mm and 500 mm effective depth. So, FC prime is 28 MPa, Fy is 414 MPa. The modulus of elasticity for the steel is 200,000 MPa. Number 1, determine the depth of compression block for a balanced condition. Number 2, determine the balanced steel area required. Number 3, determine the moment capacity for the maximum steel area requirements for a balanced condition. So ito na din yung kanyang strain diagram. So, yung strain niya, yung strain ng yield ng steel is equal to the yielding strain. So, this effective depth galing dito sa pinakataas hanggang sa centroid ng reinforcement. So, this is the depth of the neutral axis. This is the compression block. This is your C. And this is your T. This is your balanced steel area. This is 500 minus C. So sa number 1, we are required to solve for the value of A. So, for number 1, so alam naman natin na A, so based sa previous discussions natin, A is equal to beta C. Therefore, C is equal to, or yun na nga, so yung C natin, nakuha natin yan kanina, na-derive natin, ito yan, ito. So C equals 600 D over 600 plus Fy. So, mag-substitute lang tayo. A is equal to, so what is the value of beta? So, since yung FC prime natin is 28, so gagamitin natin na beta factor is 0.85. So, galing yun dito sa table na to. So, if FC prime is less than or equal to 28 MPa, 0.85 yung beta factor natin. So, multiplied natin sa 600. So, the value of D is 500 divided by 600 plus Fy natin is 414. So, therefore, yung A natin is equal to 0.85 times 600 times 500 over 600 plus Fy. So, yung depth ng compression block natin is 251.48 mm. While yung C natin, so i-divide lang natin to. So yung C equals A over beta. So divide natin to sa 0.85. Yung C natin is 295.86 mm. So ito yung C. 295.86. Therefore, itong value na to is 500 minus yung value kanina, C. So this is 204.14. While itong A natin, 251.48. So, may sagot na tayo sa letter A. Letter B, determine the balance steel area required. So ito, AS balance. So, it's number 2. We can equate this. So C is equal to T. Since Fs naman dito is equal to Fy. So we have 0.85 Fc prime AB equals AS balance Fy. So if we substitute the value, we have 0.85 Fc prime is 28. Your A is 251.48 and your B is 300. So equals AS balance multiplied by Fy of 414 megapascals. So therefore your balance steel area is equal to, so we have 0.85 times 28 times 251.48 times 300 over 414. So we have 4,337.19 square millimeters. So ito yung balance steel area required. So okay na to. Then number 3, determine the moment capacity for the maximum steel area requirements for a balance condition. Since we are to determine the moment capacity, so hindi natin i-utilize yung balance steel area. So yung maximum niya, so yung AS natin maximum is equal to 75% lang ng balance steel area. So para ka nag-compute ng maximum mo equals 0.75 of raw balance. So yung AS natin will be equal to 0.75 times AS balance. So yung AS na gagamitin natin, so ito na nakuha natin kanina, multiplied natin sa 0.75. So we have 3,252.84 square millimeters. Now, kunin natin yung yield strain. So since yung tensile strain natin is equal to yield strain, that is equal to Fy over elasticity of steel. So that is 414 divided by 200,000. So megapascal, so that will be equal to 414 divided by 200,000, and that is 0.002. So when you strain, your strain is 0.002. So let us determine the corresponding reduction factor para sa ultimate moment or sa MU. So, ang nakalagay dito. So, since the tensile strain, so, ang meron natin dito is, so, ang reinforcement natin is not grade 280 but grade 414 kasi 414 MPa. So, it shall be Fy over ES or the modulus of elasticity. That is still equal to 0.02. So that is equal to 0.002 pa din. Dahil same formula lang naman. So therefore, we use phi equals 0.65. So, yun yung standard reduction factor natin. So, tinulot natin dito. Okay, so that is 0.65. So, now, we solve for MU or the ultimate moment. So, yun yung pagsabing moment capacity, yan yung ultimate moment natin. Kasi USD tayo. So, we have phi AS Fy times D minus A over 2. So, ito yung moment arm niya. D minus A over 2. So, now, we have MU equals 0.65. Multiple yung AS na nakuha natin, 3252.84 times Fy of 414 multiplied by 500 minus A natin is 251.48 over 2. So, divide natin sa 1 over 1,000 squared para bigyan tayo ng unit na kilonewton meter. Kasi naka-newton mm yan. So, solve natin. So, we have 0.65 times AS 3252.85 times Fy times, so we have D minus A over 2. So, divide natin sa 1 over 1,000 squared. So, we have 327.6 kilonewton meter na design moment or moment capacity. So that is 327.60 kilonewton meter. So that is the design moment or the moment capacity for the maximum steel area requirements for a balanced condition. So, hope you enjoyed and appreciated the video. So, abangan yung mga susunod pang videos. Keep on watching. Sa mga hindi pa nag-subscribe, subscribe na kaya. And hit the notification bell button. Thanks, viewers.